This is Prakash Kumar, and in this video I am going to cover the basics of dynamic mesh dictionary used for producing the dynamic mesh in OpenFOAM. This dictionary is available in the wing motion tutorial under the transient case in constraint folder. This dictionary defines the mesh morphing control and the physical parameter for the rigid body. It also covers the 6 degree of freedom solver, what it will actually do, and additionally it will also give us the definition of force and the motion constraint on the body. Starting with the dynamic mesh dictionary, first we define the type and the lib_s. In the type I define it as the motion solver, and in the libs function I define it the library that I want to import. Next we define the solver as the 6 degree of freedom motion. Additionally, we define the patch as the wing that we want to study in the simulation. Next, we define the inner and the outer distance. These two parameters are very crucial for the mesh motion. Anything of the mesh inside the inner distance directly moves with the mesh nodes as a rigid body. Anything outside the outer distance, there will be no morphing that is gonna occur. Between the inner distance and the outer distance, the mesh node are morphed. Define the mass of the body, which act as the entire mass of the wing that we have assumed. Next, we define the center of mass. It is actually the point at which the centroid of the body is considered. Additionally, we define the moment of inertia. One thing to note, it is not the radius of gyration, it is actually the moment of inertia in the three principal axes for the body. We define the orientation of the body. It is the initial orientation we want the wing to be. This is made through a rotation matrix which looks similar to this one. Next, we define the angular momentum that we want to provide the body. If it's given a negative sign, the wing will move in the anti-clockwise direction. And if it's given positive, the wing will move in the clockwise direction. Next, we define the g value, the acceleration due to gravity. Rho infinity, we define it as 1, and we want it to be written in a report form. Different types of solver like Newmark, Carl Nicholson, and SimpElectric. The third one we define it in our mesh motion solver. Next we move on to the constraint part. Constraint are a list of motion that constrain the body. These directly control the permitted motion of the body. These are very different from the restraint that we will look in a while. They do not generate any force, but they simply restrict the motion of the body. There are different keywords that we can use in constraint, like axis constraint, line constraint, plane constraint, or a point constraint, or even an orientation constraint. For this case, we have used the line and the axis constraint. The name that I have defined is Y line and Z line, clearly stating that we want it to be constrained in Y and Z axis. For line constraint, we define the center of rotation and the direction. For Z axis constraint, we only define the axis, that is the Z axis. Next, we move on to the restraint part of the dynamic mesh dictionary. Restraint are the actual force that we want to apply to the body and see its motion regarding the forces. There are different types of forces that we can apply in a restraint, such as important keywords in restraint are constant force, linear damper, spherical angular damper, linear spring, linear axis angular spring, and tabulated axial angular spring. For this case, we only use the vertical and axial spring. The vertical spring actually defines the translation motion of the wing motion file, and the axial spring defines the rotation of the wing. Here we use the anchor that is same as the center of moment that we want. Next, we define the stiffness and the damping factor. Changing this factor will actually affect the rotation constraint that we want the wing to rotate. Similarly, for axial spring, we define the stiffness and damping. A very less value of stiffness and damping will result in very small change in the angle of attack and vice versa. So this was all about the dynamic mesh dictionary that I have used for dynamic meshing my wing motion tutorial. Thank you.